Hello everyone. This is my presentation of the peer-graded final assignment for the course Machine Learning Foundation for Product Manager from Duke University. The goal is to build a model to predict the electrical energy output using a training dataset of about 10,000 records, provided as a CSV file. We will use Google Vertex AI and AutoML to build our model. I'll quickly go over the instructions provided by the course professor, just to remind you of the 5 steps required to complete the assignment. In particular, I wanted to highlight that I used Google Vertex AI for all 5 steps. First of all, it is necessary to sign up for the Google Cloud Platform, and then you can access all the tools, including Vertex AI. You only need a Google account. For completeness of information about Google Vertex AI, I'm also providing the instructions for signing up and details about the free usage period offered to first-time users. Here is the Google Cloud homepage. Important: do not activate the full account. You can access the Vertex AI dashboard by using the search function. At the bottom, you'll find options for creating the dataset and for creating and training the model. Note that the input file is tabular, and all columns contain numerical data. Specifically, the target variable is numerical. Therefore, when creating the dataset, you should choose the data type as tabular and the objective as regression, since we need a regression algorithm based on this information. After, select the data source as the file in CSV format from your computer. So select the CSV file that was provided for the assignment from your PC folder. After uploading the file, then generate the statistics. With the statistics generated and the numbers visible, you can now proceed to train the regression model. Choose the objective as regression and the model training method as AutoML. Enter the model description, select the target column in the dataset, and leave the data split setting as default and then continue. Here, choose to include all the columns from the dataset. Important: set the processing time budget and enable early stopping. Then start training. Now training is running. Here you can monitor training progress. Training completed in about 2 hours. Is it a short time? Now you can evaluate the model using the evaluation metric values. Pay particular attention to the 2 main features. Okay. Now let's create a second model by modifying the features so that we can make a subsequent comparison. Let's repeat the same steps as before. For the second model, exclude the 2 minor features. Training the second model using only the 2 main features. Alright, it's finished. And this one also took over 2 hours of processing time. Take note of the evaluation metric values now that we have only 2 features in the model. Select the 2 models to compare their evaluations and metric values. Let's compare the 2 models. Note the better metric values for the first model. Conclusion: the first model outperforms the second model across all evaluation metrics. This suggests that including all features, as done in the first model, leads to better predictive performance compared to using only the 2 main features in the second model. Therefore, the first model is more accurate and better suited for the task. One last thing to mention: the free trial budget was consumed during the processing of the 2 models, with an average cost of €20 per model. Thank you for taking the time to watch my presentation. I greatly appreciate your feedback and look forward to your review. Your insights are invaluable as I continue to learn and grow. Please feel free to connect with me on LinkedIn.